recording going. So I guess I'm recording. Yeah, okay, cool. All right, so today we're going to talk about we're going to talk about two things. First, we're going to talk about something called the call stack, and that's going to lead us into a discussion of recursion. So let's talk about the call stack. Does anybody, have you heard this thing, call stack? No. Does that come up? No? Yes? I'm hearing, seeing some nods. I heard some no's. So let's just start from scratch. Let me get rid of this. All right. I'm going to pull this over here. I have written these nonsense methods that really don't do anything. It's not important what these methods do. What we're going to talk about today is the order that they're called in and how the computer deals with multiple method calls. Okay? So actually, I want to get something over here. So I'm going to pretend this is the call stack over here. So the call stack is really just a list the computer keeps. That's the simplest way we can think about it right now. And it's a list of what's being called and when it's being called, right? So up here I have this method 1. I just call it method 1. It takes in a number. If that number is greater than 5, it calls method 2. If not, it just returns the number, right? Again, it doesn't really do anything. It's not important that it does anything. We're going to get to the order in a second. Then down here, here's method 2. Let's get rid of this right for now. And let's say method 2 just takes a number and multiplies it by 3, okay? And then it returns that number. All right, so we're going to walk through this. So down here, I'm going to call method 1. So first of all, we're all good about defining methods, right? Cool. So I'm going to call method 1 down here. So over here in my call stack, which is this list the computer's keeping, doing it all by itself. You don't have to make this up yourself. The computer is going to say, okay, method 1 got called on line 15. So I'm going to add that to my call stack. Great.
Is the call stack, it's like a ledger that keeps track of how many times you're calling the method? Is that right?
That is a good way to start thinking about it, like a ledger, right? Another way to think about it, I was going to get to this in a minute. An analogy I hear all the time is like a stack of pancakes, right? Like you make a pancake, you put it on the plate. You make your second pancake, that goes on top, right? You make your third one, that goes on top. To get to that first one, I got to go down through the other 2 I made, right? Assuming that you can't flip, you know what I mean? You can't flip. We're not going to talk about that part. Just assume that you have to eat those first 2 to get to that bottom one, okay? So method 1 is getting called here on line 15. My program is going to go say, okay, I know that there's a method 1. That's been defined earlier in my program. Let me go run that. I'm going to take this variable num, which was passed in as 8, and I'm going to use that. I'm going to go to line 4. I'm going to say if not is 8 greater than 4. It absolutely is. I'm going to run line 5. Uh-oh, I'm on line 5. There's another method call, right? So inside here, I'm calling method 2. Jump over to my call stack. Method 2 gets added on top of method 1. Got it? Now, method 1 cannot resolve until method 2 resolves. Does that make sense? So method 1 is still chilling in the call stack at the bottom, while method 2 gets called on top of it, right? So now, as far as my program is concerned, I have halted on line 5 of method 1. I am pausing here because I can't do anything until method 2 gives me something back. So I'm going to jump down to method 2. I'm going to call method 2. I'm passing the same number in, right? I could pass anything in here. I could do anything. Just for these purposes, we're passing the same number. I'm in method 2. Number gets defined. It gets multiplied by 3, which is what, 24. Then I get to the bottom. This method says, okay, there's nothing else for me to do, right? I multiplied 3 by the number I was given, and now I'm going to return that. Cool? So we all remember implicit return. This is the last thing this method did. It's going to kick 24 back, right? So now it's going to go back to the call stack. It's going to say, cool, I called method 2. I did everything I needed to do. And now method 2 is done. It has made its return. And I'm going to delete it. So now method 1 has come back up to the top. So now I come back in here. And this, as far as the programmer is concerned, this method, it turns into 24. right? Because that's what it returns. So it returns 24. The rest of this is done. This method can then return 24 as well, because it's the last thing that it did. And this gets removed from the call stack, and ultimately 24 comes out. Does that make sense? Are there any questions? The call stack would continue to get added to if we continued to add methods. So if in here, before I did that, I wanted to do like a method 3, then method 3 gets added up here. And method 2 cannot resolve until method 3 gives it something back. Cool? All right. Yeah, go ahead.
And Josh, this call stack, is this something that's going on behind the scenes?
Mm-hmm.
Okay.
Yeah, you're not going to interact with it,
Okay.
and it's doing other things. It's keeping track of variables. It's keeping track of arguments. For our purposes, we just want to understand that it's stacking up our methods, right? If you might have already encountered this in an error, if you've gotten stack level too deep. Has anybody encountered that error? Usually means you have an infinite loop, which means the computer. If you have an infinite loop, it means it's building up too much. The computer is not infinite, right? So it can only go so far. Yeah, in the back. Sean.
So is this concept called flow control? And the idea is that you're kind of typing how things are evaluated so that by the end, there's what you do. And that takes you through the call stack. As you flow control something, you're going to go through the call stack once the thing's called, right?
Yeah, so
yeah.
You're just like, yeah, so we'll see more of that as we keep going. Yeah, we'll see more of how we're controlling and how we're keeping track of this. Yes, John.
Is there any like gem or something that you can call to show what your call stack is?
Is there a gem you can call to? Yes, there actually is a way to look at your call stack. I would have to look it up, but there's definitely a way to check out your call stack.
You can do it when you test your code, like for instance, inside of the browser, you can actually look at your call stack.
Yeah, so the browser will give, if you're running JavaScript, the browser will give you things. And I know there's a way to do it in Ruby. I just can't remember right off the top of my head. But that's we can look that up, and because that'll actually be really helpful for you guys as we go forward. So I'll look that up. I'll make sure I get that info to you. That's a good question. Cool. Any other questions before we move forward? Okay. So we've talked about a method calling another method, and going down that way. So now we're going to talk about a concept called recursion, which for our purposes, we are going to define as a method calling itself. So what happens if I define a method that then calls itself? Before we get too deep into this, an analogy that is sometimes helpful for people is the movie Inception. Anybody hands seen Inception? Right? So the idea of Inception is they can enter this dream world, right? So they fall asleep, they enter a dream world, and then when they're asleep and they're in the dream world, they can fall asleep again and enter another dream world. And we start to get levels into the dream, right? And then there's a way for them to kick themselves out of the dream, which I think was just to like fall or something, create this sense of falling, and they start jumping back. But the important thing to know is, let's say I'm 3 levels deep in my dream. I can't just jump back to level 1, right? I got to jump out of level 3 back to level 2. Then I got to jump out of level 2 back to level 1, right? And so recursion is going to work in a very similar way. So let's see. Let me check my notes. Okay. Okay. So I have 2 methods here. One is recursive, and here's another thing. As we start talking about recursion, you should know that a lot of these things that we can do recursively, you can also do iteratively, which just means in a loop, right? So here's 2 methods. They're doing the exact same thing. They're taking all of the digits in an array of numbers and just adding them all up. That's it, right? So let's do that. Cool. So let's look at this bottom one first, just real quick. This is add array iteratively. I'm going to set an answer. And again, there's a 1-line way to do this, but I'm trying to break these up so that we can understand the steps. So I'm just going to use this while loop. So I'm going to set, we're going to give it an array. I'm going to set my answer to 0. And then I'm just going to loop through that array. That's wrong. Then I'm going to loop through that array until it's empty, basically, right? Each time I go through the array, I'm going to pop off the last number and add it to my answer. Make sense? So I'll keep looping through. I'll keep taking the last one, adding it to answer until it's empty. Once it's empty, I'll just return my answer, and I'll get 6, right? Any questions about this? I just want to make sure you understand this concept and how we can do this iteratively before I start talking about how we do it recursively. Okay, cool. I'm not even going to run that. We're going to get out of here. Okay. So now, here is where we have recursion. So here it is recursively. And we're going to walk through each step of this. All right. So couple of things to know about recursion. 1, we know where recursion's happening when a method is calling itself. 2, whenever we write a recursive method, and this is true of when we write a loop too, but whenever we write a recursive method, we need something called a base case. Base case. And you can just think of that as, that's my out. That's how I know I need to start going back up the call stack. That's my out. In the Inception movie, they had this idea of these things called totems, which were these things that only an individual knew about. They could check it in the dream. I think, what was Leonardo DiCaprio's? The spinning top, right? So he has this spinning top. If he spins it in a dream, it never wobbles, right? But if he spins it in reality, it'll eventually go down and wobble, right? So this is his check. So every time he's like, where am I at in my dream world, right? How am I keeping track of if I'm in a dream or not? He spins this top. A base case is kind of like that, right? It's like, am I done yet? Am I ready to start coming out yet? Okay. So in a loop, we set our base case. It's usually some kind of counter, right? We're counting down, counting down. When this counter reaches this certain number, I know that I can get out of my loop. And if I don't do that, again, you've probably seen this error before, stack level too deep. That's because maybe I set my counter, I did it the wrong way, right? I'm counting down, and I never ever reach the number I'm going to count down to. And so the computer just keeps going, keeps going, keeps going. Eventually it says, forget it, I'm done, and quits out of the program, right? Same thing is going to happen with our with recursion. So we need to set a base case. We need to have a thing that says, like, this is the end. Now I need you to return. Cool? Okay, so let's walk through this. So our base case here is going to be when our array length is equal to 1. I'm setting that right now. When that happens, just return. I have array.pop, but really when our array length is 1, it's just going to be an array of one thing, right? So it's just going to be one number. And the only reason I'm doing pop is just to get it out of the array. That's it. But really, I'm just saying, return me the last thing. When you get to the end of the array, return me the last thing. Otherwise, if the array is not equal to 1, then run this code on line 6. And you know what? I'm going to split this up even further just so we can visualize it a little better. It helps me. Hopefully it helps you. Okay. So I'm going to come in here. My array, so we're calling it down here. We see this on line 12. I'm calling this array with 3 things in it. So my call stack is going to say, we're always calling add array recursive. So I'm just going to label them 1, 2, 3 because we're going to call it 3 times. But just know it's always this. Cool? So my call stack is going to be like, great. I'm going to add that to the call stack. We're going to enter inside this array. Inside this method. Sorry. Cool? Array array.length is equal to what? The length. What's the length? 3. So we do not run this code, right? It's not equal to 1. We skip 4. We go to our else. We run line 6. Line 6 takes which number off? 4, right? And saves it to this variable. Then it says, take this variable, take this number 4, and add it to whatever this call kicks back, right? So now we're in the second time we call this, 2. Cool? So far, so good? All right. And let's actually, we're going to keep track down here of our variables. So our first time through, our array is going to equal 2, 3, 4. And our last number, did I do letter? I keep doing that.
I was getting a little confused.
Yeah, my fault. That's my fault. I was originally doing this reversing a string, and then I was like, the number is easier. Okay, sorry. Are we back on track? Last number. Last num equals 4. Cool? So now remember, this first time we call it, we pause here. We're paused on line 7. We cannot resolve this method because another method has been called. It just happens to be the same method. Cool? Great. So now we're going to go another level, and we're going to call 2. So now we're down at 2, and we pass it array. So what is array equal to here?
2, 3.
2, 3, right? Because we popped 4 off. So by the time it gets here, array equals 2, 3. Cool? We run this same stuff again, right? So the array is here, it's 2, 3. We go here, we say array.length equals 2, so it does not equal 1. We skip all this, we come down to line 6, we pop off the last, so this last letter equals what? Or last number, I keep saying that, equals 3. Cool.
Isn't it adding it?
Yeah.
To 4?
Not yet, we're just right here. That's why I separated these. So we're just on line 6, what happens? Pops off the last number and saves it to this variable. So now it equals 3. So now this number, last number equals 3. It says add that to, oh, okay, we're calling it again. So what is the array equal to at this point? 2. It's just an array of one thing, right? So now, 3. So now we're getting 3. The third call gets added to our call stack. Is anybody's brain hurting? Good. Mine kind of is. All right. So now we're in our last one. We're finally there. Our array is just 2, right? Array equals 2. Is array.length equal to 1? Oh, finally, right? So array.length is equal to 1. All I'm doing is array.pop, which returns what? 2. It just returns 2, right? Great. So now 3 has finally resolved. We finally resolved one of our methods. So we're at 3. 3 has finally returned something. We hit our base case, right? We hit our out. It returns 2. So 2 gets returned, and we jump back up. This gets removed from the call stack. We jump back up to 2. So now we're in our second method. And where did we pause? We paused on line 7, right? Line 7, so let's fill this in actually. So let's say we're in our second call. Last number equaled what? 3, right? We have it right here. So we can imagine last number equals 3. And then this was the third call and it returned 2. This turns into 2. Cool? Now, there's no other methods to call. We're going back up the stack. Our second call 2, says, okay, I can finally finish line 7, which equals 5. And that's it. Now I'm done. There's no more code. I just have an end and an end. So I return the last thing I did, which was add 5. And I kick that up now to 1. So now I'm in line 1. So so now I'm in method call 1. 2 returned what? 5. So that was this right here. This turns into 5. Last number was what? 4. These are 9, right? That equals 9. Nothing else for me to do. I've resolved this. I'm at the end. There's nothing else left. This is gone. There's nothing else left on the call stack. There's no more deeper I got to go or no more levels up I got to go. And finally, this returns 9. All right, that was quite the journey that we went on. Questions? I'm going to say this about recursion. It is a difficult thing to wrap your mind around. It is a difficult thing to wrap your mind around. And the best way to do it, to start to understand it and kind of push it in your brain, is to practice it. And boy, are you going to practice it today. So if you're feeling a little lost, I just wanted to let you know that that's normal, right? It's a hard thing. I definitely did not get it the first time someone explained it to me. I had to go over it a couple of times. But are there any general questions that I can answer? Because I know that that was a lot. Sean.
I have a very specific question. So sometimes if you want to evaluate something, use or to basically it'll be true if either one is true, right?
Wait, say that last part again.
Sometimes when you can use a conditional or, right? If you want to evaluate the truth of something, right? And so,
Yeah, you could say this is true or this is true.
Yeah. So can you use that between two function calls? See if either one is true. Go down like recursively. Like my point is like, say you have a function call A, a function call B, and you're saying return A or B, right? These two function calls. Right?
If I understand what you're saying, I think you can do that.
Okay.
Yeah, but I'm not 100%. Any other questions or comments? Someone want to say like, I'm feeling a little confused. Questions or comments about where we're at? Yeah, Mark.
Can you actually run that? I just want to see.
Yeah, absolutely. That's what a great idea. Why don't we run the function we wrote? Okay, so here it is, right? I think I got it. Cool. So we're expecting what out of this? 9. So let's run this. Let me get in there. CD. There it is. Got it?
Yeah.
Cool. Other questions? Remote, do you have questions? Kind of. Still working through it. All right, I'm seeing a lot of blank faces, so I'm getting a little worried. But I feel like getting into the challenges is going to be really helpful. Here's the takeaways I want you to have for this. Okay, the call stack is a really important concept to start putting into your head, right? That as these methods are being called, they're getting added to this call stack. With recursion, we're just adding that same method over and over again, right? We're calling it over and over and over again. It's super important that you have a base case, that you have some way out. Otherwise, it'll just keep calling itself over and over and over again, and then you'll get caught in an infinite loop. Because of that, I encourage you when you're testing these to test them with very small data sets. So here I have an array of just 3 things. I think one of the challenges for today, let me check, I had it up, is the factorial. Implementing a recursive method to basically factorial you already did, but you're going to implement it with recursion now. And start with small numbers. Don't pass it 100, all right, because it'll blow up. Yes, Jackie.
Oh, I was just gonna ask, like, when is this the application of it? Like, when are you gonna use recursion versus just a regular loop?
That's a great question. So when are you going to use recursion versus a regular loop? Recursion is helpful when we need to repeat things, but you're probably thinking like, okay, well, we can also do that with a loop. Sean, did you have something to add?
My understanding, it's not used predominantly unless you're doing really deep learning, where you have to evaluate a ton of things where it's impossible right now.
So yeah, so Sean's saying that when you're doing stuff like machine learning and stuff like that, where you might have to write multiple loops to do that, recursion can come in handy. Recursion, like something like the factorial, it can be a really quick, elegant way to get that done. At a certain point, iteration is actually going to be faster, I believe, if you pass it a big enough number than recursion. For our purposes now, Jackie, to answer your question now, the biggest reason we're showing you this is because it's going to come up on a job interview, guaranteed, right? They're going to ask you, do you understand recursion? It shows that you understand the call stack. It shows that you can wrap your head around a different way of doing things. Yeah. I would say like at higher levels, it's going to come up a lot more. As a junior, I don't know if it's going to come up a ton other than in your interview, but it's really important that you understand it. Yes.
So recursion, I think the definition is it's a method that calls itself.
A method that calls itself, yeah,
Okay,
or a function that calls itself.
So line 2 is where we declare the method.
Yes.
And then is it line 7 where it's calling itself? So
Yep.
to speak? Okay.
Yep. And the thing that gets confusing is like before when we had, remember I had method 1 calling method 2, calling method 3, and it was easier because we could see them, right? But really what's hard here is we have to imagine like we're looping back around back into the method. So that's what makes it a little bit different. That's why I was trying, and I don't know if I was succeeding, to be like 1, this happens, right? 2, this happens, right? So it's like, it's calling the method again. It's like basically like rerunning all of this stuff. So I think what gets confusing is we think we're in the same thing, but we're just like in another instance is not the exact right word, but we're in another instance of that method, right? Like it's getting invoked again and run again, and it's separate from the first one, right? Other questions? No? Okay, cool. Let me stop this recording.